Right. All right. So greetings, scholars. Let's see. No real announcements. We're here. I'm still working on midterm grades. I kind of got held up. But you know, it's not anybody's fault. It's just the nature of the beast. So the midterm grades should be updated within the next couple of days because I got past the hardest part. Your midterm grade, all it is, it's just a snapshot of where you are at this moment in time. It's going to be based on all assignments from the beginning through exam 2, right? So that means exam 1 and exam 2, and then homework and quizzes. The weight is going to be a little bit skewed where 80% of the midterm grade is going to come from your exam average, and then the rest is going to come from the homework average and the quiz average. But your midterm grade has no bearing on your final grade whatsoever. It's just a snapshot of where you are at that moment in time. If your midterm grade is lower than what you would like, you are welcome to go back and like either submit any missing assignments or improve your scores. If you are submitting old assignments to boost your score, I would encourage you to do your exams first, because that's where you're going to get the most bang for your buck, because they have a heavier weight. Once you get your exam scores to wherever you would like them to be, then I would encourage you to do your quizzes and save your homework for last. The homework is like a lot of work for little points, right? So I don't want you like stressing out trying to like finish all that homework and then you won't really see your grade improve by much. Yeah. Okay. So on Monday, we were working on section 2.1 quadratic functions. So we're going to continue the same topic here today, where we're going to work on as many of the corresponding homework questions from section 2.1 together as we can. Let me check something real quick. Okay, I think everybody else is good. .3 p.m. is this one. Oh man, we got a few assignments. 2, 1, 2, 2, 3, 2, 3, and then 3, 1, and 6, 4. So yeah, today we're working on 2.1. Hey Google, give me a random number between 1 and 19.
Here's a random number, 15.
15. Okay. So this one says a quadratic function f is given below. Determine whether the given quadratic function has a maximum value or a minimum value, then find its value, and then find the range. So we have a U-shaped curve because the highest power is a 2. The leading coefficient is negative. That means our U-shaped curve opens downward, right? If the U-shaped curve opens downward, that means we have a maximum value. So it should be A, or the first one in this case. And then what is the max value? So for a U-shaped curve or a parabola, the max and min values occur at the vertex. So if we can find the vertex, then we're going to find the corresponding y value. That'll be our max. In this case, it'll be our maximum value. So I'm going to use the vertex formula. The vertex formula is h equals negative b over 2a. And this takes us straight to the x coordinate of the vertex, okay? So our b in this case is 16. So we're going to have a negative 16 over 2 times our a is negative 2. I'm just taking my notes here, right? So notice we have a double negative going on, so that becomes positive. 2 times 2 is 4. 16 divided by 4 is 4. So the x coordinate of the vertex is going to be 4, okay? So then let's use this to go and find the corresponding y. 4 squared is what? 16 times 2 is 32. So that's a negative 32. 16 times 4, 64. 64 minus 32 is positive 32. 32 minus 27 is 5. Right, so it looks like when x is 4, the corresponding y is 5. So the maximum value should be y equals 5. What's the range, right? So we have a U-shaped curve that opens downward. It has a maximum value of 5. So then the very bottom is going to be negative infinity and the very top is going to be 5. So negative infinity up to 5. Because the function actually touches the 5, we're going to use a square bracket. Infinity always uses parentheses. Okay. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 7.
So also with my students earlier, I think with all the classes, we've all done pretty much different questions. If you want to see more of like questions like these, just I guess I do need to update my YouTube, and it's there. I just need to organize it. But I would encourage you to you can watch my sessions with my students from earlier today. So my 9 a.m., my 2 p.m., and this is my 3, and I'm going to have a 4 p.m. as well. For the following problem, find a quadratic function that has the given vertex whose graph passes through the given point. Write the function in standard form. Okay. So a quadratic in standard form, it takes on the form a times x minus h quantity squared plus k. All right. So that's how we write a quadratic in standard. So then if we plug in what's given, now I don't think we have any information on a just yet. Our x is going to be 3 minus our h is 4 squared plus our k is 2, and that should equal 6. So I plugged in my h, my k, my x, and my y. Okay. So then if we simplify this, we get a 3 minus 4 is negative 1, squared is positive 1. So then we have a plus 2 equals 6. So that means a equals 4. Okay. So I'm just going to take my notes here. So then if we plug in our a, we're going to have x minus our h is 4 squared plus our k is 2. So that should be our quadratic with the necessary conditions. I'm gonna get rid of these notes. Okay. So we can at least we can verify that this quadratic passes through, has these conditions. Notice our h comma k is 4 and 2. When x is 4, 4 minus 4 is 0. So then the only thing that's left is going to be the 2. So that checks out. When x is 3, 3 minus 4 is negative 1. Squared is 1. Times 4 is 4. Plus 2 is 6. Right? So when x is 3, the corresponding y is 6. So that checks out as well. So I'm going to submit this. Okay. And again, if I'm talking too fast or going too fast, or if I need to write something out, just request it and I'll write it out. All right, let me check on you guys in Zoom. You can also feel free to type it in the chat. The chat looks good. I think we got everybody for attendance. Whew. Okay. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 16.
16. Okay. A quadratic function is given below. Determine whether the given quadratic function has a max or min value, then find the value. Okay. So the leading coefficient is negative, so that means our parabola opens downward. That means we have a maximum value. Okay. So then the maximum value is going to occur at the vertex. So I'm going to use my vertex formula, h equals negative b over 2a. Okay. So my b in this case is 18. So I'm going to say negative 18 divided by 2 times my a is negative 3. I'm just taking my notes here, right? So double negative is positive. 2 times 3 is 6. 18 divided by 6 is 3. Okay, so that's the x coordinate of the vertex, but the maximum value is going to be the y. So we need to take this x and find the corresponding y. 9 times 3, that's going to be a negative 27. What is that? 30 plus 24 is 54. So then I think negative 27 plus 54 should be 27. And then 8, right? So the corresponding y is 8. So I'm just going to submit 8. Go with that. And again, all I did was plug in that x value that we found. I plugged it into the function to get this 8. So then if our parabola opens down and we have a max value of 8, then the range being the very bottom to the very top is going to be what? Negative infinity to 8. Parentheses, negative infinity up until 8. Because the graph touches y equals to 8, then we're going to use a square bracket. Okay. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 10.
Let me see, graph the given function by writing it in standard form and then using transformations on this. Okay, so we need to write this in standard form. So to write this in standard form, we're going to use completing the square. I know I've done at least one demonstration on completing the square. If you don't feel comfortable with completing the square, I would encourage you to watch a couple of like videos of other content creators demonstrating completing the square. I'm going to low-key do another demonstration now, but the more you can kind of see this from multiple angles, the easier it is for it to sink in, all right? Okay, so the first thing with completing the square is that the leading coefficient needs to be a 1, and it is a 1 in this case. So then the next step is going to be to add 0 in the form of plus b over 2 squared minus b over 2 squared, right? So I'm going to take some notes here. We got x squared minus 2x. Now, my b in this case is negative 2. So negative 2 divided by 2 is a 1. Negative 1 squared is positive 1. So I'm saying plus 1 minus 1. So I'm adding 0 in the form of plus 1 minus 1. So then what happens when we do this, if we focus on the first 3 terms, this allows us to factor that into a perfect square binomial, right? So those first 3 terms we can factor into, it looks like it's an x minus 1 quantity squared. And then that x plus 1. No. Yeah, we're good. Yeah, x minus 1 squared. Yeah, that's good. And then we're going to say minus 1, right? Because that minus 1 just kind of trails. Okay. So I kind of said everything audibly here. If I need to write it out, just request it. Let me see. So this should be type an equation. So I'm going to say y equals. Okay. Now we could check by foiling. If we foil and simplify, we'll get back to the original. Okay, but I think this is good. I'm going to just go with this. So then in this form, we can actually graph using transformations, right? If we start with the parent function y equals x squared, where the vertex is at the origin, there are 2 transformations at play here. This tells us if we start with the inside, we have a minus 1 on the inside. That tells us to go to the right by 1. And then we have a minus 1 on the outside of our base function. That tells us to go down. So the final graph, all it is a parabola with the vertex as the origin. Then we move it right 1 and down, right? Shift it 1 unit to the right, and then 1 unit. I was doing the thing. 1 unit down. Okay. That's not trivial. It's not simple and obvious and easy, but that's why I like these kind of presentations, because I feel like by now, hopefully you all have some like sense of what you would do on your own. And then when I give the explanation, you're like, well, damn. I feel like one of maybe 3 things is going to happen. Like either you're going to be like, oh, well, I was trying to do it different, but maybe I can try what the professor did. Or you might be, okay, yeah, that's exactly what I was going to do. So you're in the clear there. Or you might just be like not paying attention or like completely lost and like, you know, just way off in left field, right? Those are like the outcomes that I see. But, you know, again, I'm just trying to encourage you all and show you like, and again, the way that I'm doing it is not the only correct way. You know, you can either try the way that I'm doing it or try something else. Like there are alternate routes that actually work, right? Okay, so let's graph this guy. Let me see. I'm going to use my parabola tool. I'm just going to click. I just clicked randomly. Now we said we had a U-shaped curve, but we went right one and down one. So I'm going to slide this to the right by one, and then I want to go down by one. Okay. I'm going to hit save. So all we did was take a U-shaped curve, we went right one, down one, and I'm going to submit that. So then the vertex, so once we have it in standard form, that identifies our vertex. Because in standard form, it's x minus h squared plus k. So we see that our h is 1 and our k is -1. So 1 comma -1. Let me check, let me finish this first. The axis of symmetry. The axis of symmetry is going to be the x coordinate of the vertex, so that's going to be x equals 1 in this case. So for the x-intercepts, we're going to be setting y equal to 0. Now we could just factor, I guess it would be simple to factor in the original. This is fairly easy to factor. If we set the original equal to 0, we can factor out x from both of those terms. We're going to have x times x minus 2 equals 0. So that means x equals 0 or x equals 2. And you can confirm that by looking in the graph. But again, all I did was set the original to 0 and solve, and then I use factoring. So 0 comma 2. And then the y-intercept, if we set x equal to 0 and solve, we're going to get 0 in this case. Ooh, I am sleepy. Yeah, I feel like every time we meet, I said it at least once. I've been struggling. Like, I don't know. I mean, I kind of got a little bit of a nap today before I met with you, started meeting with you all. But I don't know. I think that if I weren't meeting with you all, I would be asleep. Like, I would just be in a deep, deep sleep at this hour. But I keep weird hours. I'd be up for hours in the middle of the night from like maybe 2 until like 4 or 5 every day with no alarm. But that's when I do a lot of my work as well. So it's like when I wake up and I feel fresh, then I'll like grade papers and stuff like that. I've been like that since college. And my life didn't get better until I just embraced that aspect of myself. There was a good stretch. I would try to force myself to go back to sleep, and I would be tossing and turning and like laying awake for hours in bed. And it wasn't until I met somebody, and she was like, you know, when I wake up in the middle of the night, I just get up. And if I'm tired, I just go to sleep. So I built my whole life around matching my own rhythm instead of trying to force it into this circadian rhythm that they told us we're supposed to have. And then once I honored my own rhythm, I actually started healing. You know, you give the body rest and give it what it needs, it heals. Your mind becomes clear, you know, it can replicate, and, you know, the cells can replicate and do whatever they need to do. So, you know, so I do get sleepy. I mean, I'm only awake now because I'm meeting with you all. But if I wasn't with you guys, I would be taking a good nap in my hammock somewhere. All right, let's do another question. But don't get it twisted. I like to be here for you guys. Like, that's why I try to go out of my way to be here. I only ask for money because I have to, right? Because that's how our system is set up. If we didn't have to worry about money, I would probably still do this anyway. Like, even if I wasn't paid, as long as I have a place to stay, food to eat, and I can get support when I need it, the rest of it, you know, I'm indifferent. Yeah, I would still be doing this anyway. This is what I think. Hey, Google, give me a random number between 1 and 19.
3.
Okay, let's look at 3. Nope. Did I click on? What did I? Okay. Choose the graph that represents the function. Okay. So they gave us a quadratic in standard form. It's just a parabola. It looks like we moved it to the right by 2 and then down by 6. It's A looks promising. It looks like it's been moved right 2 and down 6. B went to the left. That's wrong. C is upside down. That's the wrong orientation. And D went up where it should have gone down. So A is the only one that looks promising. Hey, Google, give me a random number between 1 and 19.
2.
2. Let's look at 2. I'm kind of proud of myself, though. I didn't even game. I usually will get on the sticks. I know what I call it sticks. This is an iPad now, but between like classes. But I don't do. I try not to do it between classes because it eats into my energy. So it's like it either frustrates me or it stops me from taking a nap. Then I have even less energy for you guys. So I was like, no, let me just take a nap. Kind of try to be ready. Identify the graph of the following quadratic function, right? Okay, so I want to say it's in standard form again. We have a U-shaped curve. We went to the left by 2. We did a vertical stretch by a factor of 3, and then we flipped it vertically, right? So it should be upside down and tall and skinny. We said we went, left by 2? So the only one that fits those conditions looks like it's B. A is too wide, so you can, and it took the wrong movements. It didn't go side to side. So we would scrap A. B, I think, matches everything that we said. C went the wrong direction and went to the right where it should have gone to the left. And D, they didn't do the vertical stretch. They're missing so much. I don't think they did anything in D. So we went with A. We went with B. Okay. Hey, Google, give me a random number between 1 and 19.
7.
Okay, so let's go to 8 since we've done 7 already. Determine the quadratic function of this form who's given to the right. Okay, so they give us the vertex and a point on the graph. So let's take some notes here. So we're going to use the quadratic function in standard form. So we're going to say A times x minus h quantity squared plus k. So that's the quadratic in standard form. Let's see. So we don't have any information on A just yet. Our x is going to be what? Is that -6 minus our h, let's do some parentheses here, is -7. So they're trying to trip us up with these signs. Not today, right? Our k is 0. That's the y coordinate of the vertex. And this should equal our y value, which is 1. Okay. So then if we simplify this, let me see, double negative is positive. 7 minus 6 is going to be a 1 squared is 1. So it looks like A equals 1. So then if A equals 1, then if we plug in our A, H, and K, let me see, we're going to have x minus our h is what, -7. So x minus a -7 becomes x plus 7 squared. And our k is 0, right? So I think it's just x plus 7 squared. Let me get rid of these notes. I hit enter, okay? I meant to check it before I submitted it, but I guess I got a little squirrely, a little froggy, and I decided to jump. Okay. I'm so sleepy. Oh, we're already halfway, the party's almost over. What a bummer. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 9.
And I think I'm also intentionally being a little bit silly just to bring some kind of life to this and just to kind of keep my energy up, right? Because I could talk like I guess that's an outdated reference, but your eyes, dang, I had it in my mind, but I can't say it out loud. Dry eyes, red eyes guy. If you have dry, red eyes, please find the quadratic. I could talk like that, but then you might hear my head hit the table, go like, and then that might be it for a while. So anyway, Determine the quadratic function of this form given to the right. So this is kind of a repeat, but maybe a little bit more challenging than the one we did before, right? So let's give it a go. We're going to say a times x minus h quantity squared. I'm just taking some notes here. Plus k instead of writing it. So again, fine line between lazy and efficient. I don't think we have any information on a just yet. Now, for x, I feel like I'm leaning more sort to the point on the left because it's a 1. I feel like it might be easier to work with. But actually, I'm going to use the point on the right. So I'm going to let my x be 3 minus our h, looks like it's 2, quantity squared, plus our k is -8, so that becomes -8. And all of this should equal our y value, which is going to be -7. Okay, let's see. So then 3 minus 2 is a 1, squared is 1. So then we have a minus 8 equals -7. We add 8 to both sides, a equals 1. Looks like a equals 1, right? So then if a equals 1, and we go back and plug in our a, h, and k, we're going to have x minus our h is 2, quantity squared, plus our k is -8, right? So -8, and I think that's it. Let me get rid of these notes and let's confirm these points. What's the time? Okay. So when x is 1, the corresponding y should be -7. Let me see, 1 minus 2 is -1, squared is 1, 1 minus 8 is -7. When x is 2, the corresponding y should be -8. When you plug in 2, you get 0 minus 8 is -8. And then when x is 3, you're back to -7. 3 minus 2 is a 1, squared is 1. 1 minus 8 is -7, right? So this quadratic does pass through those 3 points. And it has the vertex 2, -8. So yeah, we're going to go with this. Okay, let me check on you guys in Zoom. We lost somebody, but that's okay. Hey, Google, give me a random number between 1 and 19.
1.
I think we have not done it. Okay, we'll do 1. Identify the graph of the following quadratic. So it's a U-shaped curve. We multiply the outside by a number between 0 and 1. So that's going to cause a vertical shrink by a factor of 4. So it should be short and wide, and it should be upside down. So it has to be either A or C. We didn't move it up or down or left to right, so it has to be C. We're going to go with C. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 5.
Let's try to hang out for like 10 more minutes. Find a quadratic function of this form that passes through, what? Okay. So they gave us the x and the y, so we need to find the a. So we don't know a, but our x is what? -2 quantity squared, and this equals 8. So then -2 times -2 is a +4. 8 divided by 4 is 2. So it looks like a is 2, so we're going to say what? 2x squared. Okay, let me just check and make sure that this works. So when x is -2, -2 squared is a +4. 4 times 2 is 8. I'm going to go with it. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 11.
Okay. All right. Graph this function by writing it in standard form and then using transformations. Find the vertex and all this other stuff. Okay. So they want us to write this in standard form. All right. Wait, dare take notes here. I really should. I'm going to try it here, taking notes. If it gets too jumbled, then I might write it out by hand, which I probably should do. So in order to convert this into standard form, we're going to use completing the square. And the first goal of completing the square is to get that leading coefficient to be a 1. I'm going to do this by factoring out -2 from the first 2 terms. I'm only going to do it from the first 2 terms. Okay. So if I factor out a -2, then I'm going to be left with x squared minus 8x, right? Parentheses, and then the -7 can persist on the outside. All right. So if we distribute, we get back to the original. Okay. So then now the portion inside the parentheses, we can do completing the square by adding 0 in the form of plus b over 2 squared and minus b over 2 squared. So our b in this case is -8. -8 divided by 2 is -4. Squared is a +16. So we're adding 0 in the form of plus 16 minus 16. Notice my use of parentheses here. Notice that that -2 still applies to that -16. So when we get ready to move that -16 out of the parentheses, we need to multiply by that -2. Okay. So now, if we focus on the first 3 terms, that we should be able to factor that into a perfect square binomial. I think I'm saying that right. Anyway, so then we're going to have -2 times, what is that going to be? Is it -4? X minus 4 squared to the power of 2. So now, in order to move that -16 out, we need to multiply it. Can I get rid of that? Okay. We need to multiply -16 times -2 to give us a +32. 32 minus 7 is 25, all right? So we need to say plus 25. Okay. Okay, so I kind of said audibly some of the stuff that I would write out in this case. So hopefully that was okay. I'm going to get rid of these notes. And I mean, we could check it if we were to expand this out and condense it and like combine like terms or whatever. We should get back to this original, but I'm just going to go with it. Okay. So now if we're using transformations, what is it saying? Remember when we do multiple transformations in one go, oh, I just missed it. We work our way from the inside to the out. So we're starting with a U-shaped curve at the vertex. Then it says to go right 4, stretch vertically by a factor of 2. It should be upside down. And then we go up by 25. I think the only one that did all those transformations is C. Where the black is the original, and then the blue is the new. That new blue, right? So we're gonna go here. Okay. So then the vertex in standard form, remember, is A times X minus H squared plus K. So our H is 4 and our K is 25. So then 4, 25. Okay. 10 minutes. So the axis of symmetry is going to be the x coordinate of the vertex. That's going to be x equals 4. X-intercepts. Can we just look at the graph? We probably could just look at the graph. Once we have it in standard form, it's pretty easy to solve for x from there. If we set the standard form equal to 0 and solve, subtract 25 on both sides, maybe I might be a little bit, well, let's keep going. We subtract 25 on both sides, divide both sides by -2, we're going to have 25 over 2. Then when we take the square root, we have plus or minus 5 over the square root of 2. So then it's going to be 4 plus or minus 5 over the square root of 2. So we couldn't look at the graph, right? Let me write that out. 4 plus or minus 5 divided by the square root of 2, right? So initially I was thinking, well, maybe we could just look at the graph and get these, but because of that radical, you're not going to be able to just look at the graph and see that, right? So if we tried to eyeball it, it wasn't going to be right. Okay, so it should be this one. Let's go with this. And again, all we did, we set the standard form, we set that equal to 0 and solve. Okay. And then for the y-intercept, that one oftentimes is easier to find than the x-intercept. For the y-intercept, we just set x equal to 0, and you can quickly see that the result is -7. Okay. Is it? Hey, Google, give me a random number between 1 and 19. Hey, Google, give me a random number between 1 and 19.
2.
So let's do 4. Match the function with its corresponding graph. So they already gave us the quadratic and standard form. So U-shaped curve, we go left 5, stretch vertically by 2, and then go down 4. So left 5 and down 4, the only one that's even close to that is A. So we're gonna go with that. B and C are upside down, so they have the wrong orientation. D went to the right where it should have gone left. So we're gonna go with this. Hey, Google, give me a random number between 1 and 19.
1.
So the next one looks like a 6. Find a quadratic function that has this vertex and passes through that point and write it in a standard form. So first I'm going to start with the quadratic function in standard form. That's our a times x minus h squared plus some k, right? That's just the formula. I don't think we have any information on a just yet. Let me see, it passes through the point. So our x is going to be 2 minus our h is 0, quantity squared, plus our k is also 0, right? So all of this simplify, and this should equal our y value, which is -8. Okay. So then we get 4a equals 8, -8. So then a equals -2. So then we're going to have -2 times x squared. I think that's it. I think it's just -2x squared. Because the vertex is at the origin. So it cancels out the h and the k. Let me get rid of my notes and then kind of just check before I submit. So when x is 0, y is 0. When x is 2, 2 squared is 4 times -2 is -8. That's about the best we can do. I did my best. It's not your fault. It's not your fault. Hey, what are you doing, man? Stop that. I don't know if y'all know that. Okay, we got time for maybe one more. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 12.
Wow. Okay, let's look at 12. I think I'm just going to go ahead and let this be the last one. For this equation, determine whether the graph opens up or down, find the vertex, axis symmetry, x and y intercepts. Yeah, this is definitely going to be the last one. Because the leading coefficient is positive, that means our parabola opens upward. The vertex, so we can use the vertex formula. Our h, which is the x-coordinate of the vertex, is going to be -b over 2a, okay? Our b in this case is -2, so double negative becomes positive. So that's going to be 2 over 2, which is 1. So then the x-coordinate of our vertex is a 1. Then we need to find the corresponding y. So if we plug 1 into the original, 1 minus 2 is -1, minus 15 is -16. We get rid of these notes. So the axis of symmetry is the x-coordinate of the vertex, so that's going to be x equals 1. X-intercept, so we have it in standard form. Can that be factored? Can we find two numbers that multiply? Is it 3 and 5? So x plus 3 and x minus 5. So then the x-intercepts are going to be -3 and +5. And then the y-intercept, if we let x be 0, we'll get -15. What were the coordinates of our vertex? 1, -16. So I'm going to choose my parabola tool. I just clicked 2 random places, right? We said 1, -16. So I'm going to drag my vertex to the proper location. And then I think we said when x was 0, we got -15. So I'm going to drag the second point to 0, -15. And that looks good. I'm going to go with that. All right, gentlemen, are there any burning questions before we go our separate ways? Any burning questions?
Professor?
The chat looks decent. Yes.
Every time I try to log into Pearson, it says that my access code has expired, and I'm not sure if I'm supposed to pay for another code or if you have one that I could put in.
Have you already bought a code?
No, I remember like at the start of the semester, you gave us a code to use, and I believe that expired. So I'm supposed to just buy a new one.
Yeah. The whole point, we were waiting. So the original code was a temporary code. It was temporary access. They ended up giving us like an extension. It was like 4 weeks of temporary access. They finally resolved the discount. So to get the discount rate or whatever, you have to go to the Morehouse bookstore and tell them that, hey, I'm trying to purchase the discounted rate for my math lab. And what it should cost $100, and that should give you 2 years of full access to my math lab for $100. And then you use that to gain full access.
All right, thank you.
Any other burning questions? Going once, going twice? All right. So if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. And I'll see you next week, same time, same place. Take care, guys. Peace.